We are working in this lesson in October-November 2017, paper 42. Okay, and we're kicking off with question 6. We are told that there are 100 students in group A. The teacher records the distance, d meters, that each student runs in 1 minute. Results are shown in the cumulative frequency diagram. So we have distance at the bottom going from 100 to 400, and we have cumulative frequency going up our vertical axis. In this case, we didn't have to plot it. It was given to us plotted already, so it's just a case of using this graph to get some answers. They ask us for various different things. First one being the median. Now the median is the middle piece of data. So if we have a total of 100 pieces of data, the median is at 50. So frequency of 50, we can head across to our graph and then down to read the distance. So this is a bit of an odd scale because they've skipped out a few numbers. So let's add in here. This will be 150 on this one, 250 on this one, and 350 here. So we're going from 250 to 300. So we're going up in 5, 10. So there's 260, 270, 280, 290, 300. Yes. Okay, so, and we bumped into that one at 280 was our reading. So our median is 280 meters. And there's that lovely clue of the units sitting here, that your answer should be in meters. So we should be reading it off the horizontal axis. Okay, so our upper quartile, that's at 75% of our data. So 0.75 times 100 would be 75. So we go along halfway between 70 and 80. And then we come all the way across. And we hit our graph again and we come down to read off the meters. How many meters is this? And it is 310, 320. So the upper quartile is 320 meters. The next question, funnily enough, asks us for the interquartile range. Now, to use the interquartile range, you're going to need upper quartile minus lower quartile. So we know the upper is 320. What is the lower? Well, we need to go to 25% of the data. So 0.25 times 100 is 25. And we come across. And we come down. So that is 210, 220, 230. So the interquartile range would be 320, the upper, minus 230, the lower, which gives us 90. So our interquartile range is 90 meters. The last one asks us the number of students who run more than 350 meters. So we look at our graph and we see these are all the students that run up to 350. The ones we want are these ones here between 350 and 400. So it corresponds to these students at the very top. So we need to come up from 350 and we read across and we get 90. But remember that 90 represents these students here, which is these lengths here. So it is not just 90. 90 represents the students who run less than or equal to 350. So those who run more than 350, we need to do 100 minus that 90 equals 10. So there are only 10 students who are running more than 350. Just that little piece that adds on at the top. So this was 6A, and we talked about Group A. When we move to the next piece, we have 100 students in Group B as well. Teacher records the distance, d meters, Each one of these students runs in 1 minute. Same thing. The results are shown in the frequency table. So again, we have 100 to 200 to 250, 280, 320, 400. So if we compare 100 to 400 are our outside limits, we're dealing with the same sort of thing, but our data is presented very differently. Now we have groups of distance and the number of students in each group. The first piece asks us to calculate an estimate of the mean distance for group B. An estimate, okay, which means we're not going to be able to get an exact value, and that's because our data has been grouped. So in order to estimate the mean of group data, we need the mid-class value. For each of those classes, what's the value that's right in the middle that we can then use to represent that class? So let's add a little space here, mid-class. So halfway between 100 and 200 is 150. Between 200 and 250 would be 225. 250 to 280, well, the quickest way to do it, if you're a little bit wobbly, 250 plus 280, all of that divided by 2. That gives us 265. From 280 to 320 is back to straightforward, 300. 320 to 400, 360. So now we've got the middle of each of those ones. Now to estimate the mean for the group data, we're going to take the middle times the frequency plus the middle times its frequency plus the middle times its frequency, and we're going to add all those together. We're going to divide by the total number of students. So our mean is going to equal the middle times its frequency, which is our number of students, plus the middle times our frequency, plus the middle times its frequency, plus the middle times its frequency, and plus the middle times its frequency. All divided by the total number of students, which is also the sum of all these frequencies. And we had 100 students. So our mean comes out at, we can plug all of this into a calculator, one time, one calculation. And then it reduces the chance of mistakes being made on subsequent calculations. So type it in very carefully, multiplications and additions, and then as equals, and you're going to get 250.2. Haven't told anything about those rounding, if there's anything weird going on, so there isn't. So 3 significant figures. 250 meters is our estimate of the mean. Continuing with these 100 students in group B, question asks us to complete the histogram to show the information in the frequency table. So if we head back to our frequency table, but we've got to keep our little brains turned on, right? Because we have different class sizes here. And if we check our histogram, we've got frequency density plotted on that vertical axis. So we need to actually calculate the frequency density before we can complete that histogram. So what have we got? Frequency density is frequency over class width. We've got frequency, but we don't have class width. So we're going to need to do that. So let's do it up here. So it's all nice and together. We'll call it CW for class width. 100 to 200, that's the width of 100. 200 to 250 moves us 50. 250 to 280 moves us 30 only. 280 to 320 is a 40. 320 to 400 is an 80. So now we can do frequency density, because we can do our frequency divided by our class width. And I'm actually going to do it at the top of my page. I don't really give any space to do calculations here by the graph. And it's very nice if all our details are together. So moving up, FD for frequency density. So the first one would be 20 divided by 100, so 0.2. 22 divided by 50 gives us 0.44. 30 divided by 30 is a challenge, that one's a 1. 16 divided by 40 gives us 0.4. And 12 divided by 80, 0.15. Now we're going to take those values and we're going to plot them. And what's really lovely is you can see they've done the first block for you. And 0.2, you can confirm your calculation was correct. So I've got these written down here as well, so that we can actually work on the graph and I can still see the numbers. So from 200 to 250. So this is 200, this is 300, so 250 is here in the middle. Our frequency density was 0.44. So if we have a look here, we're going up in 0.246810, no, but that wants us halfway there. So it is a horrible scale, 4, 8, 12, 16, 20. Yeah, we're going up in 0.4s, which is disgusting. But they say we're going to do it, so therefore we shall do it. So from 200 to 250, our value is 0.44. So 0.44, so just above there, because the next one will be 0.48. So just above that line, easier to be more accurate with a pencil than this digital pad, but you get the idea. And we do this, of course, with a ruler. You don't do this freehand when you're doing it on paper. Next one is 250 to 280. So there's 300, 290, 280. So there, our frequency density is 1. So we're going all the way up to the very top of our graph paper piece here. All the way up with a ruler, beautiful straight line with a pencil. Okay, the next one goes 280 to 320. So 300, 310, 320. And we're going up to 0.4. So beautifully straightforward on the line and down. Last one goes 320 all the way up to 400 to the end, and it's a 0.15. Okay, so we had 0.4, 0.8, and then 0.12. So it's going to be just above the 0.12 line before the 0.16 line. And again, all the way across to 400, because our last group is 320 to 400. So something similar to that, but done with a pencil and a ruler and beautifully accurate, completing the histogram showing the information in the frequency table, converted to frequency density because we have unequal class widths. They then bring us in part C. For the 100 students in group B, the median is 258. Complete the statement. On average, the students in group A run blank than the students in group B. So if we go back to group A, what was their median? Their median was 280. So group A median equals 280. So their median is higher. How much higher? 280 minus 258 gives us 22. So group A is running 22 meters further than group B on average. So 22 meters further than the students in group B. So that's a nice introduction and overview of cumulative frequency, estimating means for group data, and working with a histogram. Question 7 continues with the theme of statistics, looking at probability. So our diagram shows 2 fair dice. So 6 sides, all 6 sides have the equal probability of being rolled onto. The numbers on dice A are 0, 0, 1, 1, 1, 3. So it doesn't go 1, 2, 3, 4, 5, 6. The numbers on dice B are 1, 1, 2, 2, 2, 3. When a dice is rolled, the score is the number on the top face. So then we're all clear, we know exactly what it is we're working with in this question. Dice A is rolled once. Find the probability that the score is not a 3. So if we've got that 0, 0, 1, 1, 1, 3, they're saying not a 3. It can't be the 3, but it could be the zeros or ones. And there are 5 different options out of 6 faces. So 5 out of 6 is your probability. Dice A is rolled twice. Find the probability that the score is 0 both times. So first off, what is the probability of a 0? Well, there are 2 zeros on dice A out of 6 possible options. If we're going to roll it twice, scoring 0 both times, it would have to be 0 and 0. When we say and in between, we're going to multiply. So 2 out of 6 times 2 out of 6. And then we can do some beautiful cross counseling here. That is a 1, that is a 3, that is a 1, that is a 3. That gives us 1 out of 3 times 3 is 9. So our final answer is 1 out of 9. They then tell us that dice A is rolled 60 times. Calculate an estimate of the number of times the score is 0. So this is not asking us for a probability as an answer. It's asking us for a number of times. And you've got to think about it. In terms of, out of 60, how many would I expect? And this is just like what we worked with fractions. The proportion of the 60 rolls that would be zeros. And we know that probability of 0 is 2 out of 6. Therefore, 2 out of 6 times 60 is going to give us that number of times. And that's going to give us, well, 2 out of 6, 1 out of 3, 60 divided by 3 is 20. So we would estimate, if you throw the dice 60 times, then 20 of those will be zeros. So 20 times. Moving on with the question, we stay with these dice. Dice A and dice B are each rolled once, and the product of the scores is recorded. Complete the possibility diagram. So here we've got these simultaneous events, and we want to know what's happening. So in order to get a good idea of that, it's very helpful to have a diagram like this to understand what's going on. So product of the scores is recorded. So this is a product grid. Makes sense. All our zeros give us zeros. 1 times everything gives us the thing. So let's carry it on. 1 times each of these would be 1, 1, 1, 3 again. 2 times each would be 2, 2, 2. 2 times 3 is 6. And that's going to carry on for the next couple of rows. Then we have a 3 times a 1 gives us a 3, 3, 3. 3 times 3 is 9. So that is all the possible products that we could get from the different rolls of these 2 dice. Then our questions relate to our possibility diagram. Find the probability that the product of the scores is 2. So we have to count how many 2s have we got out of all the possible options for our products. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 2s out of, well, 6 times 6 is 36 possible options. 9 out of 36, we can most definitely simplify that. So our final answer is 1/4. The next one asks us, find the probability that the product of the scores is greater than 3. So 0 doesn't count, 1 doesn't count, 2 doesn't count, 3 doesn't count either, because we want to be greater than that 3. So we're looking at 6, 6, 6, and 9. So there's only 4 in this case out of 36. This also simplifies. This is 1 out of 9. So our final answer is 1 out of 9. So that possibility diagram is so helpful, and it's so important when understanding the question, understanding the possible outcomes, and then doing our probability calculations. Next piece of this question, last piece of this question, says that Eva keeps rolling dice B until 1 is scored. Find the probability that this happens on the 5th roll. So it means she doesn't get a 1, 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 and then she gets a 1. But that has to be the 5th roll. So we need to know what the probability of not getting a 1. So dice B, not getting a 1. So 1, 2, 3, 4 out of the 6. And the probability of 1 is 2 out of 6. Okay, 2 ones out of all those 6, plus 4 out of 6, plus 2 out of 6 equals 1. So the probability that it's on that 5th roll is going to equal not 1 and not 1 and not 1 and not 1 and not 1 4 times, and 1. We're joining by ands, so it's all about the multiplication. So it would be 4 out of 6 times 4 out of 6 times 4 out of 6 times, there's the 4th one where she's still not getting the 1, and then on the 5th one, she gets that 1. This one, you plug into a calculator, and the answer that you get then is 16 out of 243, and that doesn't simplify any further. Our final answer is 16 out of 243. So probability, it's really about understanding the situation that you've got, and when you start linking things together, are you linking with ands and ors? So in each case we've done here, we use and multiplied. If it had been a case where we were using or, she did this or she did that, then it would have been a case where we needed to add the probabilities. So always make sure that you've got a good idea of what's going on in your situation and that you read your questions very, very carefully.